Inferential statistics. In inferential statistics, one of the important thing is hypothesis testing. In hypothesis testing, we frame a question and validate the question with a test. Whether we will accept the null hypothesis or reject the null hypothesis or fail to reject the null hypothesis, what we will do in hypothesis testing. I'll take you through the step-by-step process of hypothesis testing, including the theoretical concept. And please make proper notes because this is one of the guaranteed questions you will get in internet interviews. In data science interviews, you will definitely get questions, at least a couple of them on hypothesis testing. Okay. Now, hypothesis testing is comparison of means or averages of two or more than two classes or levels with a numeric variable in categorical variable. So hypothesis testing is comparison of means or averages of two groups or more than two groups in comparison with a numeric variable. Now, simplistic terms, it will tell you the relationship between. See, how will you find relationship between two numeric variables? Relationship between two numeric variables. How will you find out? How will you find out the relationship between two numeric variables? We have already discussed covariance and correlation. Covariance and correlation. If you want to find the relationship between two numeric variables, you have covariance and correlation. But if you have to find a relationship between one numeric variable and other categorical variable, then can you use covariance and correlation? We cannot use covariance and correlation if one of the variable is non-numeric or numeric. Then we have to understand the relationship using hypothesis testing. Hypothesis testing is used when there is a numeric variable and a categorical variable. It is also used when you are finding. You can also find it the relationship between two non-numeric categorical variables. If you want to find relationship between two non-categorical variables, so we have to use. Then also we have to use hypothesis testing. So hypothesis testing is comparison of means or averages, not median, nothing. It is only comparison of means or averages of two groups or more than two groups. Okay. Now, the fundamental assumption. The fundamental assumption of hypothesis testing is the means or averages must be different. the means or averages of the classes or levels must be different. Now, how do we find this? Using the group by function. Group by function plays a very important role in hypothesis testing, because the first thing you need to check is the means or averages of the groups must be different. If you remember yesterday in analytics with the HR analytics, we have done some questions. See, average length of service of is promoted 0 and 1 is equal, is different or not. See, like this, the means of the group should be different. See, avoid ones. The groups means here there are two groups: people who are promoted, people who are not promoted. And then we are trying to find out whether the people who got promoted has higher average training score, people who are not promoted had lower training score. That is the general assumption, right? Generally, people who get promoted will have better training scores. People who don't get promoted will have not better training scores. That's a general assumption. So the group by function is telling us there is a difference in means. So whenever you run a hypothesis test, the first step is to run the group by function to confirm the fundamental assumption that the means are different. Only when the means are different, then only you will conduct the hypothesis test. If the means or averages are equal, you must not conduct the hypothesis test, because there is nothing to study, right? If both means are equal, what is there to study? When they are different, we can study what is causing the difference, why is the difference happening, what factors are leading to that difference. That thing we can study if the difference is there. If both the means are equal, that means there is no point of studying anything there. So the group by function will help us to know whether the averages are different or not. The averages or the means must be different. Then only we will conduct hypothesis testing. Clear? This is the fundamental assumption. The second assumption is, which we generally don't consider in machine learning, but in statistics it's a very important assumption of the numeric variable. There will be a numeric variable, right? Must be numerical, continuous, closer to normal distribution, with minimum outliers and no missing values. Now, statistics says the numeric variable must be closer to normal distribution. It should not have missing values. The outlier should be minimal. But always remember, normal distribution is a hypothetical situation. In real life, you will never have a normal distribution or bell curve. So this assumption, which is a statistical, more of a statistical assumption, we will ignore in machine learning. Okay, even though the numeric variable is not normally distributed, we will still conduct the test. Okay, so these two assumptions you have to keep in mind, the fundamental assumptions. Now, within the inferential statistics, there are many tests. There are many tests. The one test which we are very popular and we are going to use is, the first test which we are going to refer to is, when you have one numeric variable and other variable is categorical with exactly two levels. One variable is numerical and the other variable is categorical with exactly two levels. Then we conduct a test called two sample independent t-test. we will conduct an hypothesis test called two sample independent t-test when one variable is numerical, the other variable is categorical with exactly two levels. Exactly, not less, not more. With exactly two levels in the categorical variable. Classic example of t-test is gender. As of now, gender we are taking it as male and female, but in some companies, gender is more than two levels. The third level is the LGBTQ. LGBTQ is already added as a third level in gender in some European companies and some American companies, but not all companies. Okay, as of now, gender has exactly two levels, male and female. But maybe in future it might become three levels. So take for example, you are studying the performance of male employees and female employees. How will you compare the performance? You cannot compare male to female, right? Because there will be obviously more male employees and less female employees, right? And then you can't compare them one to one or like that. So what you will do, you will take the average of the performance of the male employees, you will take the average of the performance of the female employees, and you compare those averages, right? That is what we do, right? We compare those averages. Now, these averages will have a difference. Male has a higher average, women have a lower average, let's suppose. Now, this difference, is it a big difference that affects our decision making? That is what this hypothesis test will tell you. The hypothesis test will tell us whether the difference in means between two groups is statistically significant or not. If it is statistically significant, then we have to take that variable into consideration when building a model. If it is saying the difference in means is not statistically significant, we can ignore that variable when building the model. You're getting it, right? The means are different. The hypothesis test will tell you whether the difference in means is statistically significant or not. If it is statistically significant, it becomes a critical variable in our decision making. If it is statistically insignificant, then you can ignore that variable in your decision making. Right? I will further explain as we go through the example. Now, take for example, we will first conduct a two sample independent t-test. What is the average item underscore outlet underscore sales of different item underscore fat underscore content? What is the average item outlet sales of different item fat content? Yesterday's Big Mart data only we are working on. Just run all the cells in the notebook and run this question. Now, how will you know? You have to first use the group by function. How will you know this? You have to use the group by function. What is the average item outlet sales of different item fat content? Now, item outlet sales is numeric variable. Item fat content is non-numeric categorical variable. How many levels we have in item fat content? Two levels, low fat and regular fat. So exactly two levels. It meets the criteria for two sample independent t-test. So Big Mart train df dot item outlet sales dot group by Big Mart train df dot item fat content dot mean. 2,157 is the average sales per IJKLM, low fat. 0 is low fat, right? 0 represents low fat and 1 represents regular, alphabetical order, right? L comes before R, right? I, J, K, L, M, N, O, P, Q, R. Yeah. 0 is low fat. The average outlet sales of low fat is 2,157. The average outlet sales of regular fat is 2,224. So what this is showing us, the means are different. The fundamental assumption is met. The fundamental assumption is met, that the means are different. Now, once you have find out the means are different, then we have to write something called the null hypothesis. The null hypothesis have to be framed. Once you have found out that the means are different, you have to frame the null hypothesis. The null hypothesis is like this. There is no significant difference in average item underscore outlet underscore sales of different item underscore fat underscore content. There is no significant difference. What do you mean by no significant difference? No significant difference means, or no difference means what? Both means can be treated equally. Both means can be treated equally. Numerically, they are not equal. Numerically, they are not equal, but we can treat them as equally. See, in exams, the person who got 93 and the person who got 95, we treat them equally, right? Although they are not equal. The person who got 95 marks, a person who got 93 marks will get A plus grade. Anything above you get 90, even if a person gets 97, you will get A plus grade, right? The marks are different, but the grading is same. Similarly, here also, the sales are different, 2,157 and 2,224. The null hypothesis assumes that both the numbers can be treated as equally, where in fact the numbers are unequal. We are talking about statistical equality, not numerical equality. Now, the difference between the null hypothesis and the alternate hypothesis is the word no before significant difference. If you remove the word no before the significant difference, it becomes the alternate hypothesis. No significant difference means you can treat both of them equally. Significant difference means you cannot treat them as equal. So I will copy paste the null hypothesis, Control C, Control V. I'll change the null to alternate hypothesis, and I will remove the word no before significant. The only difference between null hypothesis and alternate hypothesis is the word no. So both means cannot be treated equally. Both means cannot be treated equally. No significant difference is null hypothesis. Significant difference is alternate hypothesis. Between both the statements, the only difference is the word no before significant. No significant difference is null. Significant difference is alternate. There is no significant difference in average item outlet sales of different item fat content. Alternate hypothesis, there is significant difference. That means both means cannot be treated equally. We have to treat the means as unequal. So the difference between null and alternate is the word no. Okay. Now, once you have framed the null and alternate hypothesis, the interpretation of the test output. The interpretation of the test output is based on something called p-value or probability value. P-value or the probability value. We will use p-value to test the to interpret the output. So as part of output, you will get a p-value, right? That p-value we will use for interpretation of the output. Now the interpretation of output is, the interpretation based on p-value will be only two things: reject null hypothesis or fail to reject null hypothesis. Fail to reject null hypothesis, nothing but accept null hypothesis. But we can't use the word accept in statistics. So the interpretation of the p-value is based on two things: rejection of null or fail to rejection of null. If you reject the null hypothesis, you will accept the alternate hypothesis. If you fail to reject the null hypothesis, you reject the alternate hypothesis. Since for your understanding, we will only talk in the terms of rejection and failed rejection of null hypothesis. Right? Now, how do we do that? If the p-value is less than 0.05, we will reject the null hypothesis. If the p-value is greater than 0.05, we fail to reject null hypothesis. When you run this test, you will definitely get a p-value. If the p-value is less than 0.05, we will reject the null hypothesis. If the p-value is greater than 0.05, we will fail to reject the null hypothesis. Now you may question, what is this 0.05 means? 0.05 means 5% alpha. Alpha means probable error rate. There is a 5% chance that your judgment is wrong and 95% confidence level. 0.05 means 5% alpha. Alpha means probable error rate. There is a 5% probability that your judgment might be wrong, but 95% you are confident that your judgment is right. 0.05 refers to 95% confidence level. So we will do all our hypothesis testing interpretations based on the p-values, right? We will simply go with the p-values and we will reject or fail to reject the null hypothesis directly. Okay, so we have done the null and alternate hypothesis for our two sample t-test. We are conducting a two sample t-test between item outlet sales and item fat content. Item outlet sales is numerical, item fat content is categorical with exactly two levels. We have framed the null hypothesis as there is no significant difference in average item outlet sales of different item fat content. Alternate is there is significant difference in average item outlet sales of different fat content. Now the process is we have to split the data. We have to split data into low fat and regular data frames. That means our core data frame must be split into two. One data frame that has only the data of low fat, one data frame that has the data of only regular. Right. So low fat is equal to Big Mart trained deer, square bracket, Big Mart trained deer dot item fat content double equals to 0. Similarly, regular is equal to Bigma train df square bracket Bigma train df dot item fat content double equals to 1. When you are using is equal to as logical operator, you have to give it as 2 times, because we are using is equal to as assignment operator also, name assignment operator also we are using. See here, we are using assignment operator, right? Is equal to low fat is equal to. That means it's a name assignment operator. So double equals to is logical operator. Greater than, less than, like that we have logical operators, right? Double equal to is this logical operator. We have split our data frame into 2 sub data frames of low fat and regular. Okay. Now, all of you go to Google scipy.stats. Scipy.stats is the statistical functions module. Scipy.stats. Within Python NumPy, scipy.stats is a statistical function module. Control F, type t-test. Control F and type t-test. Now you can see here, it will automatically go to Control F will search for the web things. You can see the t-test one sample, t-test underscore int. See, this is what we went. Calculate the t-test for the means of 2 independent samples of scores. Calculate the t-test for the means of 2 independent samples of score. T-test underscore int. Go to scipy.stats, Control F, and type t-test in the Control F box. It will automatically go to the statistical test, t-test underscore int. T-test underscore int means independent. What test we are doing? 2 sample independent t-test. Now I'll click on the function. See here. Calculate the t-test for individual means. See, it is also giving you the null hypothesis. Read the null hypothesis. You don't need to remember the null also. The null is there in the documentation also. The 2 independent sample have identical averages. No significant difference means what? Identical averages. It's all about English synonyms. No significant difference. That means identical averages. The populations have identical variances. By default, it assumes identical variances. So we forgot to check whether the variances are also same or not. In the group by, we have to add the variance formula also. Just add a cell, copy paste the code, Control C, because the test is assuming identical variances. Are our variance same? No, right? Variances are different. Unequal variances. Right? I copy pasted, replace the mean with variance. That's all. Just replace the mean with variance. So what we found out? Non-identical, right? Is it non-identical? No. It is assuming identical. So we have to say unequal means. We will use the word unequal means. Unequal variance. Sorry. Because it is assuming equal variances. It is assuming equal variances. But are our variances equal? They are not equal, right? 2.88 and 2.96. They are not equal. Our variances are also not equal. But the test assumes identical variances or equivalent. So we have to give an additional argument. I will tell you what argument we have to give. Right? Now, let us import the function. From scipy.stats import t-test underscore int. T-test underscore int low fat dot item outlet sales, comma, regular dot item outlet sales, comma, equal underscore var is equal to false. So since the p-value is greater than 0.05, what should we do? Fail to reject null, because our p-value is 0.08, right? You can see the p-value clearly, right? 0.08, which is greater than 0.05. So this is the process of conducting the hypothesis testing. Two sample independent t-test. So what are the first step in two sample independent t-test? First, you have to do group bys. Group by mean, group by variance. Then you frame the null and alternate hypothesis. Then you split the data frame. Then you run the test. And then you interpret the output of the test. So the steps involved in two sample independent t-test. All of you got the p-value correctly? Same 0.08.
So we use equal underscore var as a false type. What do we use to do it? What's the difference?
If you say equal underscore var is equal to true, there is a different formula. Now, because the variance is small here, we may not see the much difference. If the variance is large, then the p-value will be very different, very large different. Here, our p-values, our variances are very small. Our variances are very, very small. So we are seeing the p-value changing very, very small. When you're dealing with large data, where the variances will be very, very large variances, the p-value drastically changes. So if you take equal underscore var is equal to false, you might reject the null hypothesis. But if you take equal underscore values for the same test true, it might be failed to reject null hypothesis for large scale data. When you have lakhs and lakhs of data points, the variance will also increase, right? Central limit theorem. We call it as central limit theorem. As the sample size increases, the means and variances tend to spread out because the outliers will come into picture, right? Different size people. See, you take the height of 100 people, you will get one value. You take heights of 1,000 people, you will get one value. If you take heights of 1 billion people in India, you will get a different value. For 100 people, you get a larger value. 1,000, you might get a closer value. For a billion, it might be very, very small value because the population will be very, very things. But if you take heights of specific, like states of Punjab, Haryana, Rajasthan, they have people with more men with more than 6 feet. There you will get a higher things. But if you take south states like Andhra, Telangana, and Tamil Nadu and Kerala, we don't see 6 feet high people very much. We are in the 5 to 5'10" range. So we will get a lesser height. So the sample has an effect on the variance. Sample has an effect on the average. So that you always need to keep in mind. And you go to real-time data science, you'll be working with large-scale data sets. So you have to be very careful with the mean and the variance. Mean, median, and variance are very important. That's what I told you. Are not in the first session. We discussed a lot of things about the mean getting distorted by smaller values and higher values. There are 5 students in a class. 3 people got above 90. 2 people got 60. The average will come down to 80, right? But will that be clear? Is the right representation? Because majority of the students scored above 90. But because of 2 people scoring 60 marks, the whole average is getting distorted. But if you take the median will be 90. Right. So that is the problem we have. It happens in e-commerce data also. You have all people in India, generally people buy how much? 50,000 to 60,000, not even 50,000. E-commerce average ticket size is 20,000 or 30,000. Right. Very few people buy ACs, refrigerators, which are above 50,000 on Amazon or Flipkart. Did you see anybody buying washing machine on Amazon, Flipkart? No, right? Very few transactions we see. Those people also might have gone to the showroom, checked the machine, and then they would have ordered online because of some discount factor, cashback or something, they might have done it. So you will see that rare places where people might have spent 1 lakh rupees on e-commerce transaction. Very few transactions, but most of the people spend between 500 rupees to 20,000 rupees in India in e-commerce, both on Amazon and Flipkart. Even if a person wants to buy an iPhone, he will go to the Apple store and buy it. Will he order it online? Because we have cases where soaps came, or soap was sent as a iPhone. We have that problem, right? So people will not trust. So with the larger ticket purchases, people will not trust. Now, there are instances where a 7,500 mobile place also got a soap. There are cases on Amazon fraud where a guy bought some Mi mobile, which is 8,000 rupees. He got a soap as this thing. But will that cause any problem? It will cause less distress or less problem. But if you get instead of an iPhone of 90,000 rupees, so it becomes a big customer escalation, feedback, consumer court, all sorts of things will be done. So that is why you have to be very careful with variance and mean. They are very dangerous, particularly for large scale data points. For large scale data points, we have to be very careful. Sometimes, take for example, Ola. How many people will travel with such price? I don't travel, I'll wait. Every day, that's a problem to me. After 6 o'clock, when I start booking, Ola shows from here to my house in Vidyanagar, 1,000 rupees for sedan. It is around 28 kilometers from here to my house. 1,000 rupees sedan is very high. Hardly sedan I pay. Now prices have increased. Earlier I used to pay 420 to 430. Now they increased the prices, so it went up to 500. Where is 500? Where is 1,000 rupees? How many people will do that such pricing? Nobody will do that, right? They will wait until unless he is in a very emergency, like he's going to airport or someplace, something, he will book it. Otherwise, I'll wait for 15 minutes. Then I'll wait till the prices come down to that 500 level. It will be 15 minutes, 30 minutes or 40 minutes, I have to wait. But there will be some exceptions where people will pay that higher such pricing. So when you have such distorted values, your mean and variance will get affected. So when you work with real-time data, you will see this problem. Sometimes you will see these distorted values. So you have to make a decision. We generally delete those distorted values. If they are very minimal. If they are in very small range, we tend to distort them. Same thing happens with Airbnb. You know Airbnb, right? In India, it is not popular. If you go to abroad, Singapore or any other places, people book Airbnb with 40 Singapore dollars or 50 Singapore dollars. If I want to book a Airbnb with $100 of Singapore dollars, I would happily book a 5-star hotel with the same price. Why would I book an Airbnb with $150 in Singapore? I'll get a 5-star hotel with breakfast and a good king size bed and everything with $150. But you will also see Airbnb people paying $100 also. Because they like it, they want a homely environment, so they want to have that feel and scenario, they book it. So it depends on consumer choices. We have to look at those exceptions. And these are the exceptions which cause problems in our data sets. Because if all people behave samely, we don't have any distortion in data. We are happiest people. But because of this irrational behavior, which happens in consumers, we always have problems. We call it as irrational behavior. There is no logic. I would say, why would anybody pay $150 for a bread and breakfast in Singapore? We'll get a 5-star room with free breakfast, with a swimming pool. But some people like it and they book it. So it all depends. And we can't blame the customer. Every customer has its own thinking process, right? Irrational behavior. So that's what happens. So the variance and means are very, very dangerous. You have to be always careful about means and variances. Any doubts, participants in the hypothesis test process? So I will list out the step for two sample independent t-test. So the first step is group by. The first step is group by with mean and also with variance. Then you will frame the null and alternate hypothesis. Then you will split data into levels or classes. Then you will conduct the test and then you will interpret the result on p-value only. There is another way of doing the interpretation, but we will stick to the p-value only. Okay. Now I want you to test null average item underscore visibility for different item underscore fat content. Equal. Now we don't need to split the data. You can avoid step C. Step C, we have already split the data, right? Low fat and regular. Rest of the steps you have to do except the step C, because we have already split the data into low fat and regular. First do the group bys of both mean and variance, item visibility and item fat content. Group by of first item visibility and fat content with mean as the statistical function. Second group by between item visibility and fat content with variance as the statistical function. The first group by should be item visibility dot group by item fat content dot mean. The second group by would be dot variance dot var. Then frame the null and alternate hypothesis. Don't split it. The data is already split into low fat and regular. Conduct the test and interpret the result on p-value. Got it? All of anybody? Reject or fail to reject? Fail to reject, huh? Let us do the group by Bigma train dot item visibility dot group by Bigma train dot item fat content dot mean 0.064, 0.069, very marginal difference. Control C, Control V, change the mean to var. Variance also marginally different. Now we will conduct the test. P-test underscore in low fat dot item visibility comma regular dot item visibility comma equal underscore var is equal to false. Oh, it's less than here. How can you see? E minus 0.0, E minus 0.5. What is the value? What is the actual value here? NP dot round you remember the Excel formattings E minus 0.5 and E plus 5 comma 2 decimals. The value is see 0.0. E minus the actual value is 0.1234, 4 zeros, 1404696. This is the actual value. After E minus 0.5, right? Minus means this, plus means before. Plus means before decimal. Minus means after decimal. So 4 zeros after decimal, the value will start. What is the value? 140469. Is it less or greater than? It is less than 0.05. You can say since P value is less than 0.05, we will reject the null hypothesis. We have to be very careful to see whether it is E minus or E plus. E minus means it is less than 0.05.
What can we interpret?
So interpretation is like this. What is the difference in averages here? 0.6 and 0.69. What is the difference here? 0.005. That means that small difference of 0.005 is also a significant difference. The small difference of that 0. Like I will write it here. The difference in means, the difference in means, how much is the difference? 0.005 is statistically significant and the variable is critical variable. Critical means it's a very important variable. In the previous instance, what was the difference in means? In the previous instance, the difference in means is how much? Where is that group by? The difference in means is how much? Let's calculate now. 222.4.56 minus 2157.7, 66.8. So the difference in means, which is 66.8, is statistically not significant and it can be treated as non-critical variable. Right? Reject means it's a very important variable. Simplistic terms. In layman terms, reject null means it's an important variable. Failed reject null means it is not an important variable. Reject null means it's an important variable. Failed to reject null means it's not an important variable. Got it? Layman terms, simple terms. If a test says reject null, that means both the variables are important. If the test says failed to reject null means the categorical variable is not important. Numerical is anyway important to us. Categorical is non-important. Is it clear? Simplistic terms. There is a larger difference, but it said the larger difference is not big difference. Whereas a minute difference also becomes a big difference. That is the thing you have to appreciate in data. Sometimes very small difference also becomes a very, very big difference. Sometimes a very large difference will be treated as insignificant difference. Now, why it happens? You have to understand the formula. The formula of t-test is mean 1 minus mean 2 divided by square root of variance 1 by n1 plus variance 2 by n2. Like this, we have this mean. I will put it in the t statistic. You get the t statistic, right? Along with t value is mean 1 minus mean 2 divided by square root of variance 1 by n1 plus variance 2 by n. That is the formula for t statistic. You get the t test in the result statistic, you are getting it, right? This statistic is calculated using this formula. Mean 1 minus mean 2 divided by square root of variance of 1 divided by n1 plus variance of second variable divided by n. I'll paste the formula here also so that you can refer to it in future. Two sample independent t-test formula. See, this is the formula. Mean 1 minus mean 2 divided by variance 1 by square root of variance 1 by n1. S2 is variance, S is standard deviation. S square is variance, S is standard deviation. N is number of observations of class 1, N2 is observations in class 2. Mean of class 1, mean of class 2. So it uses this formula to calculate the statistic. Once you calculate the statistics, you can use the degrees of freedom to check the table. If you remember your high school statistics, you get printed tables along with question papers, right? To check the p-value from the printed things. Instead of doing all those things, the test itself gives us the p-value. So we will go with the p-value. All software R also gives us the p-value directly. We will blindly go with p-value less than 0.05 and p-value greater than 0.05. No other metric we will take into consideration. Right? Now, one more test. Test null. Null, the average MRP of different item fat content, item underscore fat. I am forced to use this variable because there is no other variable with two levels. That's why I'm using item fat content again and again, because I don't have any other variable that has two levels. So when we do the hypothesis testing on HR analytics, the other data we will be doing with multiple things. Here also same process, except splitting. Don't split the data. Data is already split. Group by mean, group by variance, conduct the test and interpret. When you look at the p-value, check whether it is E minus or E plus. So reject or fail to reject? Fail to reject. Sigma trend here dot item MRP dot group by sigma trend here item fat content dot mean 140 141 marginal difference. Oh, variance also very less. 112, not less, but okay. So t test underscore in low fat dot item MRP comma regular dot item MRP comma equal underscore wire is equal to false. P value is greater than 0.05. Is greater than 0.05, fail to reject null. Fail to reject null. Here, it is not critical value, no? Not true. So difference in means, what is the difference? Somewhere around 0.7, right? 0.5, no, 0.8 is not significant and variable is not critical, right? See, reject is critical. Reject is critical. Fail to reject is non-critical. Not important. MRP is not important. See, MRP is okay. Fat content is not important for MRP. Yeah. Anybody call error?
So like if I press the type item, if I tab nothing.
In what there is in Google Colab, na?
No, no, no.
Basic Jupyter only. Actually, if it is not coming, that means variable name might be wrong. 5 minutes. Yeah. If there is an error in the name, that did not print. I think that will not come. That will not come. I did not print. Dot ID in the tab. See, it depends on the process of building it solved to come. But directly variable name should not. Data frame got variable name. Sir? नहीं आ रहा है तो आपको ऊपर जाओ जहाँ सेट किया ना वो आपने बता दिया तो scroll down ये वाला यहाँ पे क्या दिया आपने यहाँ पे क्या होना चाहिए यहाँ पे होना चाहिए आइटम आउटलेट सेल्स नॉट फैट कस्टमर दोनों सेम रहने चाहिए ना यहाँ पे आप करेक्ट लिया यहाँ पे आप फैट कस्टमर आइटम आउटलेट सेल्स you are giving one numeric and one non-numeric. All right. Now, let us look at this scenario. If one variable is numerical and other variable is categorical, the other variable is categorical with more than 2 levels or classes, exactly two sample independent, more than 2. It can be 3, it can be 4, 5 or 100. Then we have to do ANOVA single factor, or also called as one-way ANOVA. If there are more than 2 levels, it can be 3, it can be 4, or it can be 5, 6, 10, 100 or 200 in categorical variable, then we have to do ANOVA single factor or one-way ANOVA. The null hypothesis is same. Let us say S null, the average item underscore outlet underscore sales for different outlet underscore type is equal. Out type is equal. Okay, the process is same. First we have to do group by. Okay, we have to do group by of only mean. Group by of only mean. We have to just do group by of mean. Then null and alternate hypothesis. Then split data. Then conduct a test. And then interpret. So this is the process. So group by with mean, null and alternate hypothesis, and then conduct the test. Test null, the average item outlet sales for different outlet type is equal. Now, interpretation is based on p-value only. Is based on p-value like similar to above. Similar to above. We will use the same p-value notation. Now, Bigma train DF dot item outlet sales dot group by Bigma train DF dot outlet type dot mean. So we have 3 types of outlets. Oh, sorry, 4 types of outlets. 0, 1, 2, 3. What is this one? LE dot inverse transform not trained here dot outlet type. Oh. Not trained here dot outlet type dot LE dot inverse apply. What are the, why should be one-dimensional array? Got an array of shape instead. Okay, we get one-dimensional array only, right? Let me check how to do inverse transform. Okay. What is predictions here? Object calls encode dot inverse transformer. Dot apply le dot inverse underscore transform. Yeah, why it is? Yeah. No, we are inverse transform. I want to know what is 0, 1, 2, 3. We got the values, right? To know what does that represent, we have to inverse transform. We have to reverse it. Then only we'll get to know what is 0, what is 1, and what is it. Earlier it was 0 and 1, I could easily find. But sometimes when you're dealing with large, you have to inverse transform. So that's what I was checking, how to do the inverse transform. I don't know why, where is the predictions coming from? Okay, why to waste time? I'll tell you in the next session. Let me check it. Dot item outlet sales, bring dot item outlet sales, dot group by not train, dot outlet type, dot mean. So grocery store. 0 represents grocery store. Then 1 represents supermarket type 1. 2 represents supermarket type 2. And then 3 represents supermarket type 3, right? So 0, 1, 2, 3, we have 4 different classes. So we can't run the t-test here. We can't run the t-test here. So what we will do is we'll frame the null hypothesis. The null hypothesis is there is no significant difference in average item outlet sales for different outlet type. Same statement, control C, I will paste it down. The null will become alternate and remove the word no before significant. No significant difference is null, significant difference is alternate. Okay. Now we have to split the data. Grocery, or let us give a simple name. GS is equal to Big Mart train DF, square bracket Big Mart train DF, dot outlet type double equals to 0. ST1 is equal to, I can copy paste this down, control C, control V, make it 1. ST2 is equal to, control V, make it 2. ST3 is equal to, paste it and make it 3, right? GS, ST1, ST2, ST3. We have split the data frame into 3. Now let us go to the statistics thing and control F, F underscore, or simply say ANOVA. See, performs one way ANOVA. Simply type ANOVA in your control F of statistics, you will get F underscore one way. Click on F underscore one way, the one way test. You can see the null hypothesis that 2 or more groups have the same population mean. Right? Same population means what? Identical means or equal means. So the null is already there. If you want, you can directly take it from there. So F underscore, oh sorry, we have to import, right? From scipy dot stats import F underscore one way. F underscore one way GS dot item outlet sales, comma ST1 dot item outlet sales, comma ST2 dot item outlet sales, comma ST3 dot item outlet sales. You get the p value as 0. Since p value is less than 0.05, what we will do? We will reject the null, which means difference in means is statistically significant. So this is the process of running the ANOVA test. You can take your break. After break, you can come back and run the test. Okay, take your 15-minute break and then test, or run the test and take your 15-minute break. So test null, the average item visibility of different outlet types. So the process is first group by mean, only group by mean. Here variance is not required. Then frame the null and alternate. Then no need of splitting the data. Data is already split. Conduct test and interpret. There is no significant difference in average item visibility of different outlet underscore type. Null hypothesis. Alternate hypothesis is the same statement. Remove the word no difference. There is significant difference. Right? Null and alternate.
So,
Yeah.
so does reject analysis means other than
Accepted, yes. So if null is rejected, automatically alternate is accepted. If null is failed to reject means alternate is automatically rejected. F underscore one way, gs dot item visibility, comma st1 dot item visibility, comma st2 dot item visibility, comma st3 dot item visibility. So p value is very less value. Since p value is less than 0.05, we will reject null. That means difference in means is statistically significant. Difference in means is statistically significant. So ANOVA means analysis of variance. ANOVA full form is analysis of variance. ANOVA single factor or one-way ANOVA, which is conducted when you have more than two levels. When there are more than two levels in your category. So ANOVA formula is very, very complicated. It is not as simple as t-test. ANOVA single factor, you have to calculate multiple formula. Which one is good table with all explanations? I think this is the one. So a lot of formulas are there in ANOVA calculation. It is a very large calculation. Then we'll also copy the how to add hashtags to all. So these are all required in calculation of ANOVA. These are the set of formulas. X minus mean whole sigma x minus mean whole square. Then sigma mean minus grand mean whole square. Then k is your number of variables minus 1. N is number of observations, n minus k. Then you will get the mean square within, mean square between, and then you get the F statistic. Like how we got T statistic there, we got F statistic here. So using the F statistic, and then we calculate the various formulas. The formula is quite complex. It is a very large calculation. But these are the set of formulas which are used in calculating the F underscore one way or one way ANOVA single factor. Got it, all of you? I'll share this notebook with you. At that time, you can look into the formula. We can also do this calculation in Excel. I will show you this calculation in Excel also. Now, till now, we have looked at one variable numerical, the other variable is categorical. And the categorical variable has either has exactly 2 or more than 2. Now, there is one more t-test. There is one more t-test if one variable is numerical and other variable is categorical with exactly 2 levels, but levels will be before and after. Levels will be before and after. In this test also you'll have 2 levels exactly, but the levels will be before and after an event. Before and after an event. This we call it as paid sample test, or also call it as related sample t-test. There is one more t-test where you have one numeric variable and categorical variable, exactly 2 levels. But the 2 levels will be before and after an event. Take, for example, blood pressure of a patient before he takes the tablet. Blood pressure of the same patient after taking the tablet, 90 minutes after taking the tablet. That type of data, we call it as before and after, or related sample data. We call it as related sample data because one person is giving you 2 data points before and after. That test, we call it as paired sample t-test or related sample t-test. The blood pressure of the patient before taking medication, blood pressure of the same patient 90 minutes after taking the medication, or sugar levels of the patient before doing the test at fasting, the sugar levels of the same patient 90 minutes after taking breakfast. So before and after. When you have the data like in this format, in before and after, only one entity will give you data points at 2 different time intervals. One entity will give you data points at 2 different time intervals. Now, the null hypothesis is there is no significant difference in average value before and after. Alternate is the same, just remove the word no from the null hypothesis. The only difference between null and alternate is the only word no. There is significant difference before and after. Here also the means must be different. The means must be different. Paired sample t-test. Now, let us do an example. Test null the average CPI, consumer price inflation of India before and after demonetization. Before and after demonetization is equal. Test null the average CPI, consumer price inflation of India before and after demonetization is equal. Now, you know when the demonetization happened? November 2016. So November 2016, we had the demonetization. So let us see India CPI EU. So we have the consumer price of India monthly CPI India 2016. So the before demonetization, what was the monthly information? 12 months before. 12 months before, what was the monthly? So November 2016, it has happened, right? So the prior is like this, you have to do before. Both are in same file. Let us separate it out. So before demon, square bracket, what was the inflations? So before demon 3.35, comma 4.14, comma 5.30, comma 2.30, comma 6.46, comma 6.13, comma 6.59, comma 5.86, comma 5.51, 5.53, 5.91. So how many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need two more. That means we have to go down to 2015 and we need the data for December and November. 6.32 and 6.32 and 6.72. Okay, after demon, I'll show you the data. 1 second, let me just fill it. So after demonetization, we'll go back to 2016, November. Okay. $2.59, 2.23, 2.59, 2.23, then 17, 2017. Then we go to January, 1.86, 2.62, 2.61, 2.21, 1.09, 1.08, 1.79, 2.52, 2.89, 2.24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, these are the values before and after demonetization. You want me to send it as a mail? We'll see. What she's saying. T-test data. Send the data. Right? Just copy from your mail, right? So mean difference has to be checked. NP dot mean, sorry, print NP dot mean before demon, print NP dot mean after demon. So before demonetization, the mean was 5.65. After demonetization, the mean was 2.22. Okay, mean is different. So we have confirmed mean is different. Go to scipy.test and see what is the related sample t-test. Control F, t-test. So within t-test, you can see here, here. Calculate the t-test on two related samples, A and B. T-test of two related samples, because these are related samples, right? One person is giving. So the sample is related. Earlier, the fat content can be low or the fat content can be regular. It cannot be both, right? It can be either regular milk or it can be low fat milk. Can it be both? It cannot be both. So they are called independent samples. A person can be male or a person can be female. He cannot be both at a single point of time. So they are independent samples. Here, one person is giving us data from two different time points. That's why we call it as related sample. So the t-test underscore related is the function. So if you click on it, you can see the null hypothesis. Now, null hypothesis is the two related or repeated samples have identical average. or no significant difference, or no significant difference. So you can find the documentation, the null hypothesis. You don't need to remember also. When you're working, you can find it from documentation. So all you have to do is you have to give the function. Oh, sorry, I have to go up. See, you have to give the two data frames, nothing, no other argument, right? So let us do that function. The function is from scipy.stats, import t-test underscore rel, t-test underscore rel, t-test underscore related before daemon, comma, after daemon. And then since p-value is less than 0.05, we will reject the null, which means the difference in means is statistically significant, because there is a big difference, right? Almost 3.43 difference is there. Inflation, you know, right? Percentage terms. 3.43% is a big difference in inflation.
Sir,
Point.
documentation for test underscore, there was one more parameter called access.
Where?
So they're like A comma B comma access.
Huh. See, do you want to compute the axis on columns or arrays? Our data is in what? Arrays. So we will give access. See, generally our data will be, see, even if you give the data in table format, in the backend it will be converted into arrays. It will be access is equal to 0 by default. If at all you don't want, you want to keep it as, that is not the right thing. So what happens is, if you give the data table, every variable will be converted into an array. What is array? A row of data, square brackets, right? So that means access is equal to 0. If you want to do column-wise calculation, access is equal to 1, which is a very rare instance. By default, arrays will be horizontal. We don't have vertical arrays, right? We always have horizontal array. Now the input which I have given is also an array. This is an array, right? This is an array. Square brackets separated by commas, elements separated by comma. Okay, that's why we are using access. Now, one more thing you should have asked. What is the other thing you should have asked? Alternative two-side rejection. In hypothesis test, we always do two-sided rejection. One-sided versus two-sided hypothesis test images. Statisticians will tell you this is the thing. You might have studied, right? One side and two side hypothesis. Two sides means you are rejecting on both sides. One sided means you are rejecting on one side. Here is a graph here. Where is the table? This is it. Copy the image. In all hypothesis tests, we have this thing. We always use in industry two-sided tests. That means we are rejecting on both sides. See, what we are saying, no significant difference or significant difference, right? Equal and not equal, means is not equal. So we are doing both sides. This is a bell curve. Rejection on both the sides. 0.25, 0.25. What is the rejection area? 0.05. We divide it by 2, 0.025. So you are rejecting on both ends. What we are doing till now is two-sided thing. In industry, we always do two-sided test. One-sided test in textbooks you see, right? If it is less than, the rejection area will be on the left side. Or if it is greater than, the rejection area will be on the right side. Mean less than X, mean greater than X. But what we are doing, we are using is equal to. We are either using mean 1 is equal to mean 2 or mean 1 is not equal to mean 2. Two-sided things we are doing. We are using two-sided test. No significant difference means what? Mean 1 is equal to mean 2. Alternate is what? Mean 1 is not equal to mean 2. You can also write it like this. Null is mean 1 minus mean 2 is equal to 0. Mean 1 minus mean 2 is not equal to 0. So that we are using the two-tailed test. Statistics says you have to remember this, okay? They will definitely ask you two-tailed rejection and one-tailed rejections. Just keep it in mind. Tool time is 0.25, 0.025, 0.025 on the both ends. Okay, mean 1 is equal to mean 2, mean 1 is not equal to mean 2 for two-tailed. For one-sided, either there will be a greater than symbol or less than symbol. If less than symbol is there, it is on the left side. If the greater than symbol is there, it is on the right side. Okay. Okay, so we have done one example of before demon and after demon. We found out the difference in means is statistically significant. Got it, right? Now, do you all know GST is implemented? When is GST implemented? July 2017. On July 2017, India implemented the GST. They removed the sales tax or the commercial taxes. They came into ethics. Test null, the average CPI 12 months before and after GST implementation. After GST implementation equal. Right? July 2017 is the implementation. Let us go to the CPI. July 2017, I have the data. So, slightly side. So, before GST, that data is July 2017, 1.08, 1.08, 1.09, 2.21, 2.61, 2.62, 1.86. Then we'll go to 2016. So 2016, let us go down. 2.23, 2.59, 3.35, 4.14, 5.30. Oh. 6.46. How many we got? 1, 2, 3, 4, 5, 6. Oh, 2.21. Why did I give 2.61? 2.62 two times. Two point two one, 2.61, 2.62. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 months data. Then after GST equal to square bracket, and then July 2017, we got the data as 1.79, 2.52, 2.89, 3.24, 3.97, 4.00. This is December. Then after December 2018, January. 2018 January 5.11. Comma 4.74, comma 4.36, comma 3.97, comma 3.96. I think we got 12. No, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. One more we want. 3.96 and 3.93. See how the Indian government forces the data. These are all dummy data. Paid data set, data 2. Yeah, I've sent out the data. Then np dot mean for GST, then np dot mean after GST. 2.96 and 3.70. There's a difference. Okay. So the null is there is no difference between average CPI before and after GST implementation. And alternate would be there is, oh, I forgot significant. Okay, null and alternate. Now connect the test. Failed to reject. Huh? So t-test underscore related before GST, comma after GST. Since p-value is greater than 0.05, we fail to reject null. That means difference in means is statistically insignificant. Oh, sorry. Yeah, there is no significant difference. The marginal difference, no? How much is there? 64.64? 0.64 is the difference, which is not a big difference. Whereas in the earlier case, 3.5 or something is the difference. That's a large difference. See, CPI is percentage terms, right? In percentage terms, anything above 1% will be significant. Particularly in economic data, it will be very significant. Because 1% change in inflation will lead to loss of almost 50,000 to 75,000 crores of GDP. So that's a problem. We are having inflation right now, right? 7% inflation, which has drastically affected our GDP growth rate. So earlier we were supposed to become 5 trillion economy by 2025. Now we are becoming a 5 trillion economy by 2030. So that is the effect we'll have. So everybody will have problem, right? In GDP, people consume less. If they consume less, customers, companies sell less. If companies sell less, they have less revenues. That means they lay off people. They will spend less on advertising. They buy less on raw materials. So it has a circular effect and it will completely destroy. People are not buying two-wheelers, right? Bikes, because they don't have money. People are not buying cars because there is no supply. Semiconductors are required, right, for cars. That is not there. So you have to wait 4 weeks to 16 weeks for cars. There's a waiting period of 12 to 16 weeks, some brands, popular cars. This car is ready, but the semiconductor is not there. The semiconductor is there in that dashboard, not digital dashboard is a semiconductor. AC control is semiconductor. Speed control is semiconductor. So you have 4 or 5 semiconductors in a car and they are not supplied from Taiwan or China, you are gone. So that is what happens. So you have to be very careful with this sort of data. Okay. Now, let us look at this situation where we have both variables. Both variables are non-numeric and categorical. When both variables are non-numeric and categorical, then we have to do a test called chi-square test of independence. Chi-square test of independence is done when both of your variables are non-numeric and categorical. When your both variables are non-numeric and categorical. The input of chi-square test of independence is cross tabulation. The input of chi-square test of independence is cross tabulation. What is cross tabulation? Cross tabulation is frequency table of two non-numeric categorical variables. So when both variables are non-numeric and categorical, we perform a test called chi-square test of independence. The input of a chi-square test of independence is cross tabulation. Cross tabulation is a frequency table of two or more also you can give non-numeric categorical variables. PD dot cross tab Bigma trained here dot outlet type comma Bigma trained here dot outlet size. Now we have outlet types and outlet size. So outlet type we already have. What is outlet types? We got them on top. Just a second. Just let me take it. So outlet type, this is the categorization, right? This is the categorization for outlet underscore type. For outlet size, we have 0, 1, 2, 3 again. 1 second. Let me go up and see what is outlet size. Yeah, outlet size we have only 3. High, medium, small. Oh, we have added missing also, right? Trained here. Missing we have added. Remember we had missing values there? We'll do high, medium, small, right? So high, medium, small. 0 is high, first alphabet, right? 1 is medium. 2 is missing. 3 is small. Because S comes last, right? Right? So we got this categorization, outlet size. So this is a cross tabulation. You can see the values in the cross tabulation. Frequency table of two categorical variables. Now, the null and alternate hypothesis here is, the null hypothesis is, there is no association, or in Indian textbooks, they use the word relationship between both variables. Alternate hypothesis, the same statement. There is relationship. There is association or relationship between both variables. No association or relationship between both variables. There is association or relationship between both variables. from scipy.stats import chi2 underscore contingency. Chi2 underscore contingency is the chi-square test for independence. Chi2 underscore contingency pd dot cross tab bigmart trained here dot outlet type comma bigmart trained here dot outlet size. So here the second one is the p-value. This is the p-value. This is the expected table which we create. Row total into column total divided by grand total. This is the p-value. Hence, p-value is equal to 0 is less than 0.05. We will reject null. That means there is a relationship between both variables. So if you go to here, go back to the table, control F, chi-square. But simply say chi. Chi2 contingency. Here. So chi2 underscore contingency, chi-square test of independence of variables in a contingency table. So you can see here, chi-square test of independence, p-value for hydro test of independence of observed expected frequencies are calculated. So we will get the values as chi-square statistic will get the value, then you get the p-value. So in the output, what we got here, this is the p-value. This is the p-value. And this whole thing is nothing but expected table. This is whole thing is nothing but expected table, which we create from the actual table. This is our actual table. From this table, we create the expected table. Oh, I think I forgot the formulas. You can do it. I'll tell you the formulas. Okay, got it, all of you? So first, let me give you the formula for paid sample t-test. I forgot the formula. T-test. So this is the formula for paid t-test. Sigma d by root of n into sigma d square minus sigma d whole square by n minus 1. D is the difference between both the means. D is the difference between both the means. Sigma d by square root of n into sigma d square minus sigma d whole square. They are different, and divided by n minus 1. That is your paid t-test formula. And then once you get the t statistic, you will get the p-value, and then based on the p-value, you will do the thing. This is your paid t-test formula, which you can easily calculate, not as complicated as ANOVA. Right? Now, one more test. Test null, there is no association or relationship between outlet underscore type and outlet underscore location underscore type. Test null, there is no association or relationship between outlet type and outlet location type. So PD dot cross tab sigma train df dot outlet location type comma sigma train df dot outlet type. Okay, you got the cross tabulation. chi2 underscore contingency, you can copy paste the PD cross tab, control C, control V. So P value is 0. That means there is a relationship between both the variables. And the formula is very simple. Observed minus see here, observed minus expected whole square divided by expected sigma.
So the reason the third term is equal to so
Pardon?
in output we get like C square value,
Hmm.
P value, we have to level the expected value.
Expected is calculated using the formula row total multiplied by column total into let me show you. Give me the numbers in Excel. One of you give me the cross tabulation numbers. Okay, give me the numbers. 0, 1, 2, and 3, right? And rows also same, right? 0, 1, 2, 3 only, right? This is the table, cross tabulation. Give me the values 0, 5. First one is how much? 5, 28. 1, 8, 6. This is 0. No, just let me, no, did I reverse it? Is this format correct? No, that's what I'm asking. If it is reversed, then I'll correct it. That's what, no? 0, 1, 2, 3 and 0, 1, 2, 3. I have reversed it, right? That's what causing the confusion. So this is the format, right? Is this the format? All right. For me, what is the format? 0, 1, 2, 3, 0, 1, 2. 5 to 8, 1, 8, 6, 0. Yeah, correct. 5 to 8, 1, 8, 6, 0. Next. 0, right? No, why it is causing me outlet type 0, 1, 2, 3 and 0, 1, 2. Previous one is correct, right? Yeah. Again 0, then next 0, 2, 7, 8, 5, 0 and 0. The last one 5, 5, 5, 9, 3, 9, 2, 8, 3, 5. Sum total should be 8, 5, 2, 3. Correct. Okay. So this is, we have to calculate row total and we also have to calculate column total. Right? This is our original table. Right? So is equal to sum of is equal to sum of right, and this will be sum of any of these two, but this is your grand total. This is your grand total. Grand total is 8523. So expected total, expected table is equal to row total multiplied by column total, row total multiplied by column total divided by grand total. This is the formula it creates using this one. So I'll copy the headers exactly below, Control C, Control V. I also copied these headers, Control V, right? Oh, made a mistake. Right? So is equal to row total, oh, sorry, is equal to open bracket row total multiplied by column total divided by grand total. Now I am going to drag the formula horizontally. Now if I drag the formula horizontally, the row total remains constant and the grand total also remains constant. If you drag the formula horizontally, row total remains constant and grand total constant. So I will press Fn plus F4 or F4, absolute cell referencing. Absolute cell referencing means you are fixing the cell. Even though you drag the formula, the cell will not change. So I drag this. So I will drag it to the side. What is happening? I'm not able to drag the formula. How to fill the formula? Control C, paste formulas and number formatting. You got zeros, sir. Did we get zeros? Huh. Why am I not able to drag the formula? I fixed it wrong the cells. That's the problem. It has to be G which has to be fixed. C should not be fixed. That's the problem. Now we will try it. Right? Same is equal to open bracket row total, which is fixed by pressing F4, multiplied by column total, which will change, divided by grand total, which is again fixed. Drag it to the side. Is equal to open bracket row total, which will be fixed, multiplied by column total, which has to change as we drag, and grand total, which has to be fixed. So you can compare this with the values which we got there. So you can see, right? 303, 1562, 260, 0.9 and 261.97, 353, 1822. The numbers are same, right? So this is how the expected table is calculated. Degrees of freedom is, 1 second. Degrees of freedom equal to number of rows minus 1 multiplied by number of columns minus 1. Number of rows minus 1 and number of columns minus 1. So num rows, how many rows we have? We have 1, 2, 3. That means 3 minus 1. Number underscore columns, verticals. So number underscore calls, we have 4 minus 1 equal to right. So DF is equal to 2 into 3, 6, right? 6 we got the calculation. So actually p-value we can directly calculate here is equal to chi-square dot test or chi-test actual range comma expected range. P-value is 0. We got 0, right? P-value. The chi-test is there. In Excel, we have the chi-test. You have to give the actual range and the expected range. If you give the expected range and actual range, you will get chi-statistic. Right? Observed minus expected or actual minus expected. So the expected table is calculated using the formula row total multiplied by column total divided by grand total. We will do this in Excel also. After a couple of sessions, we will do that in Excel also. As a revision session, sometime before your exam, there will be an what you call test for 30 marks on statistics online. That time, before the test, we will work on Excel so that you can have a practice of all the concepts. So every component you have a test as per the MSc or LMS, right? Machine learning, half of the algorithms are conducted, you will have a 50-mark test online. Again, rest of the algorithms covered, 50 marks online test. Google form, I'll send you with the timer. You can give the test and those tests will be given to the placement guys. So statistics test will happen sometime next week. Okay. So before that, I will do one practice session on Excel where we cover all the average, mean, medians, skewness, kurtosis, this hypothesis test calculations, then aggregations, group bias, everything. It's like a revision session. And then you will have an exam session, right? So I expect all of you to score minimum about 20, or I want all of you about 25 out of 30. That would be your target. Okay. All MCQs, no calculations, only MCQs will be asked. The Google form will come with timer. So you will have for 30-minute test, you will have 40 minutes or 45 minutes. Before the timer ends, you have to submit because once the timer ends, you cannot submit. And you will know your marks immediately. And you will also get the form in your email with correct answers. Okay. So these are the common hypothesis tests we do in industry. A common hypothesis test we do in. మాట్లాడాలా వీళ్ళతో మాత్రం వెళ్తున్నా వస్తున్నా 1 second. Hypothesis testing and big markers. I'll send this notebook. हेलो हेलो हाँ हाँ ये थर्ड फ्लोर रिसेप्शन में दे दो थर्ड फ्लोर को వచ్చి रिसेप्शन ఇచ్చేయండి ठीक है थर्ड फ्लोर रिसेप्शन में दे दो